good to be here. So before we start off, I want to say something about this beer. Because we actually brought our own beers to the conference. So if you look under your seat, you can find one of your beers there. No, I'm just kidding, sorry. But we will be handing out these beers at the end of the conference, so please have one. You can find a QR code on the back. And we're really good developers, but apparently not very good testers, because the barcode or the QR code isn't really working. But you can go to passionatepeople.io/quiz, and there you can find a quiz. So if you supply the answers and your email address, you can win a prize. So please do that. So today we're going to talk about REST, GraphQL, and gRPC. Who of you already used GraphQL and gRPC? Great, I can teach you something new. So yeah, small introduction again. I'm David. I'm a JavaScript developer and co-founder at Passionate People. And the whole reason why I made this presentation is microservices. So microservices, they kind of changed the landscape of a front-end developer over the last years. And you already saw Luca and Max talking about micro front-ends, so even the front-ends are moving there. But I want to teach you a little bit more about the back-end side of things. So this is what it used to look like, very simple, a few years ago. So we had a front-end application and a back-end application. Both used to be monolith. And yeah, it was pretty straightforward. They were using REST. And it's changing. So currently we have microservices, which means there's a design gap in the current setup. We have the front-end application, or multiple front-end applications, and we have the microservices. So yeah, how did we fix that over the years? So first of all, microservices, they have some advantages. They give the teams freedom when they develop a microservices to choose the technology that fits the service the best. They can scale them individually, so that you don't have to deploy several big applications, but you can just scale out the parts which are under heavy load. And you can ease the deployment process, because you can deploy them individually. There are also some disadvantages, though, because performance is one of them. Actually, microservices are not that great for performance, because the big applications that we used to have, they all worked from their memory, and memory is just way quicker than doing something over a network. Then we have testing, so we have a lot of individual elements all in those microservices. And sometimes you just don't know who uses your microservices, and if you deploy something new, you want to be sure that you don't break anything. And it adds complexity, because you end up in a huge landscape with a lot of different services. But there's one, it's working, yeah, okay. There's one really big advantage for us as a front-end developer, that we get more responsibility, because the design gap is missing, the layer between the microservices and the front-end. So that's why the BFF was introduced. So does anyone know what BFF stands for? Okay, I see a few hands. Can someone tell me what it stands for? Yeah, exactly. So it's not this. But it's a backend for frontend. So what is a backend for frontend? So I found this cool definition. A BFF, in simple terms, is a layer between the user experience and the resources it calls upon. So this is still free to interpret how you're actually going to create the BFF. So I think one of the first BFFs that were implemented, they were REST-based. So you have your front-end application, you have your BFF, where you aggregate all the data and you supply it to the front-end, and you have the microservices, which gives some other benefits, because you can do the whole authentication part on the BFF as well. And probably the microservices, I mean, they're mostly made by backend developers, and they don't always think about how something should be presented in the front end. So you can strip out some data, you can rename some fields, and you can make it easy for yourself when you call the BFF that you can basically just throw the data into the components instead of doing all the stuff in the front end. And it removes heavy load from the front end application. It moves it to the BFF, which is mostly a Node.js server, and it's way more useful to do that on the back end side. But there's also a disadvantage about REST-based BFFs. Each application, if you want to do it correctly, requires its own BFF. So for example, if we reference back to Luca and Max, their chat, they were talking about micro front-end applications. So if you want to do a BFF correctly the REST way, you want every front-end application to have their own BFF because you want to supply data differently. You might not need all the fields. Because, for example, you can have a mobile application, and this is a really simple example, of course, but you might want to leave some fields out. This is, of course, a really simple example, but if you leave a lot of fields out on mobile, you reduce the payload for the mobile user, and it will result in a faster download time. And that's really important for mobile. So you end up with this. For example, if you have a mobile and web application, or of course you can have multiple web applications, you end up with a BFF per application. So this is where GraphQL comes in. So GraphQL is great for this because it solves the design gap that we have with REST-based BFFs. But if we compare it to REST, REST is well known. Everyone knows how to use it. Not everyone uses GraphQL. So if your team hasn't used GraphQL yet, then there is a learning curve. With REST, which is one of the worst things in my opinion, there's no official standard. So everyone, if you're building microservices, for example, and you have no standard set up within the company, everyone is going to implement things their own way. So you can, for example, return a 404 when you have no response, but you can also return an empty object. And there's a lot of different implementations going on on the internet. One advantage of REST is that it does use HTTP status codes, so you can give advanced feedback to the user what exactly went wrong. And you have one API for all. So how most API providers do it, for example, if you look at a Spotify, a Google, they use includes and excludes. So you can say, I want a normal response, and I want to exclude some fields to optimize it for my experience. But of course, this is not very maintainable when you need to do this for all the different applications. And then we have GraphQL, and GraphQL basically says, okay, you just request the fields that you need, which is really beneficial in a BFF situation, because you don't need to create a separate BFF for each application. So it puts client performance first, and it also invented its own conventions. So if you look at, it's not a standard, it's something they developed themselves, which is a good and a bad thing, of course. So if we compare the REST call that we just had, so first we had two BFFs. We have an API for talks, for example, and we have a mobile API talks, and we want to leave some fields out. With GraphQL, you can solve that really easily because I just sent a different query to leave some fields out. And they're both using the same endpoint. So for example, this could be a solution, an Apollo GraphQL server, and then we still have two front-end applications, but they both call the same resource, the BFF. And one other really cool thing that you can do with GraphQL is caching. Because we share the BFF now between the different applications, you can actually set caching field-based. And Apollo GraphQL and Apollo Engine, they provide some really cool things for this. It's called a cache control decorator. So for example, if I have a product, I can say, okay, I want to have this product cached for 60 minutes. And everything else under that will be cached automatically for 60 minutes as well, but I can also override some things. So for example, if I request a stock, I want to have actual information. So then maybe if you look at the backside, then it does a request to the stock information microservice, and then it only needs to request that once every minute if someone requests the stock field. Or we could say, for example, the price should be a private scope, So each user should see his own price because maybe you can have personal discounts. So if we go back to this picture, there are a few things which are important on the front-end side and on the back-end side. So we just spoke about the front-end side. I'm requesting, as a client, information for the BFF. And what you want to do, you want to reduce the time it takes to download that response. So that's why GraphQL is great. You can just get the fields that you want. But if we look at the server, there are also some people implementing GraphQL, for example, in microservices, which is beneficial in some use cases if you have a huge response and you just want to have the fields. But on the server-to-server, how big the payload is, it doesn't really matter that much because the network connection between those services is really fast. So we want to focus on speed in a different way. So that's how we come to gRPC. So does anyone know what gRPC stands for? No? So I tried to look it up on the website. So RPC, it's an old technology. It stands for Remote Procedure Call. And I thought that it's developed by Google, so it must be a Google Remote Procedure Call. But this is what they say on the website. It's gRPC, of course. So this is what they say. gRPC is a modern, open-source, high-performance RPC framework that can run in any environment, and it can efficiently connect services. So this sounds more like a marketing pitch. It doesn't tell me anything. So what is gRPC exactly? So gRPC has some core features. So it's built on top of HTTP 2, so it's not usable with HTTP 1. You can auto-generate libraries. I'm going to show you that in a minute. It features bidirectional streaming, pluggable out, blah, blah, blah. But the biggest thing here is that it's based on protocol buffers. You can also use something else. So protocol buffers, it's a language-agnostic contract, which you can implement to stream or to serialize your data. And besides that, the protocol buffers, they guarantee type safety. Time for some code. Is this big enough? Yeah? It's a huge screen, so probably. Yeah? More? Okay, so let's look at the contract. So how you start implementing gRPC, you start with a contract. And this is my simple contract. So I have some things that don't really matter for now, but then it starts. So I say, okay, I have a greeter service, and I want it to be able to say hello. So I send a request with my name, and it should return a message. And these are the names for the fields in the response and in the request. So if we look at the server, so this is Node.js, we can start a gRPC server, and what we do, we load the hello world proto file. So that's this part. So these are just some settings that you can supply. And then I implement the function, say hello. So I get a request, and the request contains the name, and I want to return the message. So that's defined according to my contract. The cool thing is you can also export the protobuf files to TypeScript, and then you can actually use those interfaces within your code. Then I add the service, I create some credentials, and I start the server. So let's look at the client. It's really simpler. So the same setup, the gRPC setup, and I have a method which I call, so I'm just going to run it once, and I say hello with the name Frontend Developer Love. Okay, so let's run this. Oops. So I start my server, and then it returns the response. So the cool thing is that everything is based on the contract. So I can actually change the contract while the server is running. For example, I can say, okay, my second value is 2, and it's a string. And the cool thing is, I'm not supplying the string right now, but what gRPC does is that it says, okay, if the field is missing, I'm just going to provide the default value. Oh. And now I have my second value. And the good thing about this is that you guarantee type safety to your other developers. So you can do more. You can also supply enums, for example. I can make an enum with a color. And I can say red is 1, blue is 2. And I have a color, and that's field number 3. So the numbers are just field names. And then it automatically says, okay, my color is red, because it takes the first one from the enum. I can also provide a default value. For example, if I forgot to supply something, I can say default is test. Then it actually adds that. So these are really cool. Yeah, this is a really cool way to work from a contract instead of working from code. So basically, you can define the contract first and then start implementing the code. So now I implemented the client myself. So I'm saying, okay, I want to load the protobuf file. I want to call the say hello method. But this is basically a library that I just wrote, and you can also auto-generate this. So that was over here. So I never remember this vue.js command. But I can say, okay, I want to generate a JavaScript library from the protobuf file. Okay, let's remove the enum because he doesn't like that. Okay, let's remove this too. There we go. So apparently it's not working that good yet. But what it does, it generates 2 JavaScript files. So a hello world protobuf and a web protobuf. So this is just a JavaScript library which includes all the methods. And if I supply this file, and a protobuf file to one of my clients, they can actually use this library. So you can, for example, push this somewhere in an NPM module every time you make a new deployment of the microservice, so people can use this. But then, they were talking about that gRPC is really fast. So I thought, okay, let's put that to the test. Is it really fast? Okay, let's just performance, and then let's open this. So what I have here, I made a simple GraphQL server, which returns a message. So it's super lean, the most lean setup you can get probably, and I have a server. What I'm gonna do, I'm gonna request the server the message 1,000 times. Let's kill this one first. Let's do the GraphQL one first. Oh, whoops. Okay, so our Apollo server started. So how long do you think it's going to take to request 1,000 messages from a GraphQL Apollo server? Anyone can guess? 6 minutes. That's going to be a long presentation. I only have 11 minutes left. 5 minutes? Okay, let's just do it. So 2.2 seconds. Let's run it a couple of more times. 2.1. Okay, so it's a little over 2 seconds. So you can imagine if you have a microservice, for example, a microservice that supplies user information, or a microservice that checks if your token is valid. You're going to call that microservice a lot of times, and you want to optimize that microservice for speed. So that is a really good use case, for example, where you can use gRPC. So let's start the server. Any guesses how long this is going to take? It's 1,000 times again? 1,000 milliseconds, so 1 second. Okay. 100, okay, 0.1 second. Nice. Oh, whoops, wrong one, client. So it's 0.20, so it's, 270 milliseconds, so you were close. But you can see how much the difference is, and it's mostly, in this case, because it's based on HTTP2. But the good thing is that it's only usable with HTTP2, so it standardizes HTTP2, and they also call gRPC Google's attempt to standardize gRPC, to standardize HTTP2. So yeah, it's really fast, and that's really cool in my opinion. So let's go back to the presentation. So there are, of course, also disadvantages about gRPC. So the advantages are that it's highly efficient on the wire. A simple definition framework. You can see that it's really simple to implement a contract. So you can even do bidirectional streaming. So, but there are also some disadvantages. It's really hard to debug. I mean, I got some errors using gRPC for the first time, and it's so unclear what's happening. So that is a major disadvantage, and I hope they're going to improve that in the future. The tooling is also limited because it's quite new. They've been using it internally at Google for quite some time. I think it was called Stubby by the time, and it was only available within Google. And now they open sourced it, and they called it gRPC. And another disadvantage, if you have a REST microservice, you can just call it using a REST call. But with this, you actually need access to the protobuf file. So, well, like I mentioned, what you can do, for example, if you use it internally or externally, what you can do is once you deploy a microservice that uses gRPC, you can actually integrate an automatic pipeline that it also publishes an NPM module out of it. That includes the protobuf file. So in the future, for example, you can have a setup like this. So we have our Apollo GraphQL BFF. We have our front-end clients. It could be a React app, Vue app, Angular app. It doesn't really matter. And we can have our services. So you can have some old services or services that are used by the public more often in REST. You can have a gRPC service, a service that needs to be really fast and called upon a lot. Or we can have even another GraphQL server, and you can just stitch it to the BFF. So that was it. I want to thank you. And don't forget to fill in the quiz.
Thank you very much, David. So before you go off, I have a couple of questions for you.
Uh-oh.
So this is going to be nice because I was actually being interviewed with him. So now I get the chance to interview him a little bit back. So here we go. So first of all, how is it like to be part of this conference?
It's been great. I've been here last year too.
Yeah.
This is the first time I'm speaking here. But it's amazing to see so many front-end developers together and share the knowledge that we have. And yeah, it's a really cool vibe, definitely.
Yeah, I can relate to that. It's very nice. I don't know how it's about you all, but it's very nice. How do you experience passionate people at the moment, since we have grown and everything? So
yeah, so it's grown really fast. Like Luke mentioned, last year we were here with 3 people, and now we're at 32 people. But it's cool because we focus on creating a collective. We want to bring front-end developers together that are really passionate about their job. We want to win cool clients, and we want to inspire each other. So we organize sessions, for example, where we share knowledge about the different clients that we have. And yeah, basically mini conferences just for our own, and it's a cool way of sharing the knowledge in the team.
But this is not a mini conference, right?
No, this is not a mini conference.
So obviously, like 32 people in one company, we all have a very big opinion about where we should go. What is your perspective on where we are heading with passionate people?
So we try always to let the developers decide. So we, for example, we had a session last month, and we wanted to organize some workshops. And what we do, we ask all the guys, okay, what workshops do you want to see in the next month? And then we're going to organize those workshops. And I think it's important to keep the developers running the company and let them make the decisions where we want to go, because it's for them and it's not for us.
Nice. So, as a last question, this is actually a small test. Can you mention the 3 core values of passionate people?
Oh God. Caliber, community, and collective. Yeah.
Awesome. He passed the test.
Thank you guys and girls.
Thank you, David.